y equals x plus, let's do 3x plus 4, something like this. We want to be able to look at our equation and figure out kind of sort of what it already looks like, okay? So if you are given some graphs that look like this, you know, so say you're on a test and they say, which graph is this equation graphed? That instead of having to work it completely out, we can simply look at the numbers that we have, and we know it's not that I have a slope, right? So I have a slope, it's positive. I have a y-intercept, so it's not at the origin, so it's raised, so it can't be this one because this doesn't have a positive slope. Can't be this one because this has a negative slope. It can't be this one because my y-intercept is
positive, but
positive here, and this has a y-intercept that's negative. So it has to be that. Okay? So same thing. So that is the main thing with looking at equations that I was trying to help you guys look at, because as we now move into graphing quadratics, the same exact principles apply, okay? So we're adding numbers, we're adding different shapes, but the way that we look at equations and the way that the numbers are laid out are the same, okay? So when we have an equation with an exponent of 1, that's called a linear equation. Those are all the ones we did last week, okay? Now, all last semester, we learned about quadratic equations, right? Quadratic simply means you have an exponent of 2, correct? Okay, so the simplest quadratic you can have is y equals x squared, correct? Okay, so there are different forms of this. This is the simplest form, okay? Remember when we looked at a real quadratic, we say it equals ax squared plus bx plus c. Remember when we were looking at that? Because then our quadratic formula used negative b plus or minus the square root of 4ac over 2a, right? So when we look at the main form of quadratic, we have ax squared plus bx plus c. This is called the standard form, okay? When we were solving a quadratic, how do we try to solve it the easiest way? Without using the quadratic formula or completing the square, if we had x squared plus 2x plus 1, what was the easiest way to solve this?
Oh, wait, split that.
We always try to factor it first, right? Correct?
Yes.
Okay. So when we have, so this is our standard form. And I think on one of the, so on this graphing of quadratic, when you want to have this one out, you can see that this is our standard form. Ax squared plus bx plus c. So we've got this one. Then we have a factored form. That is not on this sheet. Okay, this is one of the ones you'll need to know. So we have factored form. Okay. Our factored form with quadratics gives us solutions, right? So when we solved this, we came up with x equals -1, and this one was also x equals -1, right? So this actually gave us an answer. Well, when we graph it, this answer means something specific now. Okay? So before it was just simply an answer, correct? Now this answer means something. These answers are called zeros or solutions. Okay, so we're getting some vocabulary in here. Okay? Then another way to solve to rearrange this, to solve it, we've got our factored form, we have our standard form, is to use completing the square. Remember, sometimes we weren't able to just factor it. Sometimes we have to rearrange. So if I move my C over, then I end up with ax squared plus bx, correct? So remember, when we had a squared term and then a value, we could turn this into completing the square, right? By doing 1/2 of b and then squaring it, right? So this is 1/2 b squared here. And then we would have our value, then whatever we have here, and then we could rewrite it as the whole term squared, okay? So when we have that, when we can get some value in the front, some number, with our quadratic that has actually been put into a squared term, then this is called our vertex form because it gives us also information about it, okay? So we're going to work through transitioning our equations from standard to factored to vertex back and forth using all of these. It's the same exact information. That's where we're going. Same exact information to get us the ways that we can graph it without necessarily writing a table and solving it. You can always start plugging in numbers, right? Okay, but we want to have a big picture of what it looks like. Okay, so that's where we're going with our forms. Okay, and you have a sheet that will have all of those 3 forms on it, okay? Now, when we graph a second degree equation, remember second degree equation means that we've got the exponent of 2. It can be graphed in 4 different ways, okay? So it will be a parabola, which is this shape, okay? It can be graphed as a circle. It could possibly be an ellipse, which is a squished circle, or it can be a hyperbola. Okay? And what we have in our equation tells us which of these graphs we will turn it into. All right? So over the next 2, maybe 3 weeks, we will be working through each of these forms and what our quadratic look like. And looking at what is the equation that they have given us, which of these graphs are we going to be working towards, all right? So how do we get these? I had a prop to bring, I forgot it. How do they actually get?
What are those two called on that side?
This is a parabola,
Parabola.
and this is a hyperbola.
Okay.
Okay, so how do we get these in the first place? Okay, these are called conic sections. The reason it's called conic sections, I will use this. When we have a cone, ice cream cone, and hold it like this, I will try to draw it here. When we have a cone, right, and we put a plane through it. I had little cones for us to cut. Okay, and we are going to put a line, a linear equation or an equation through this cone. Okay, we can go through the cone in different ways. If I go through the cone, through the top, and out one of the sides, okay, the angle that it goes through the cone is like this, okay? So we're going out the side. If we were to actually slice this off, the shape that we would get as it as it goes through, as it follows the curve, is going to be a parabola. Okay? When we slice through the cone. Because it's going to go curve down, and then it's going to, at the point that it comes out, and it goes back up. If we're going to slice it and look at it. Okay? If we cut through our cone straight across, right? So we're putting a paper straight through our cone. That's not a straight line. Straight through our cone. And we were to pull the cone apart exactly where we cut it, the shape would be a circle in there, right? So if I have an ice cream cone and I slice right through it and I'm looking at it, I am now looking at the circle, right? Top and bottom. Now, if I turn my slice and I'm slicing my cone at an angle, it has 2 points, but it's going to be squished, so then you get an ellipse. Okay? And if I slice my paper all the way through this cone up and down, anywhere or anywhere vertically, then we are going to have a hyperbola, because you would have a slice here, and then you would have a curvature there. Okay, so we get all of these shapes, and I'll bring the cones next week to you and do a little video. We get all of these shapes from slicing cones in a different way. All right, this is where they come from. That is why they also all come from a quadratic equation, okay? Because the one equation makes, when we graph it in a 3D plane, it makes a cone. All right? So, because, let's look at the practicality of where we're going with the quadratic. When we are graphing a linear equation, okay, when we are graphing a linear equation of y equals x, every time our base 1, right, is y equals x, so our coefficients are 1, right? Every time we move across 1, we're going to go up 1, right? So we end up with a line that has a 45-degree angle, right? And then we learned that as the coefficient gets bigger, our line gets steeper, correct? As the coefficient gets smaller, our line gets shallower. When our coefficient goes negative, then we start getting a negative slope, okay, right? So that's what we were looking at with our line. Now the base for a quadratic is y equals x squared, again, with our coefficient of 1. So let's think about it. If x equals 1, then y equals 1, correct? If x equals 2, y is now what? 4. 1, 2, 3, 4. Okay? If x equals 3, y would be 9, correct?
Yeah.
Now, remember when we were solving for quadratics? If I was to solve for this x, how would we solve for x? Take the square root, exactly. So I would take the square root of x squared, which means I would also have to take the square root of y, correct?
Yeah.
So x equals, what happens when we take the square root over here? There was something special that we did.
Fraction.
Could I just put the square root of y?
Sure.
It was plus or minus,
Yeah.
correct? When we take the square root here, we had to add the plus or minus. We ended up with 2 solutions, correct? Because 3 squared is the same as negative 3 squared, right? They're both 9. So our x value now ended up with 2 solutions. Okay, it's back from when we were solving for x, right? these two solutions are extremely important because now when we're graphing, we have two solutions on our graph. So when x is 1, or when y is 1, we have x is 1, but when y is 1, x is also negative 1. Right? So if we're plugging in our y values here, if we are solving for x and saying, what could x be? I now know that I've got plus or minus the square root of y equals my x value. So when y is 4, x is now plus or minus 2, right? Because I have 2. So I've got, when y is 4, I have the solution of x is 2. I also have the solution that x is negative 2. Okay? So when y is 9, I have the solution that x is 3. X is also negative 3 when y is 9. Okay? So because when we take the square root, we get two solutions, we now have two parts of our graph. And that is why we don't simply have a line on one side. We have what is called a parabola. So, when we have a parabola, there is always an axis of symmetry. Okay? And this is because we have two solutions. The solutions are exactly the same, but they are on opposite sides. So what we can do is we can, if we had a paper, we could take our graph it on one side, and we're going to open it up, and we're going to have it equal on the other side. Okay? So you have an axis of symmetry. Okay? The very tippy top, or the bottom, wherever it is, the point that it folds over is called your vertex. Okay? The axis of symmetry always runs directly through your vertex. Alright? You also have the places where it crosses this x-axis are your solutions. From when we had that factored form, you know, so if we have x minus, say our equation graphed out, and we factored it like that, okay? So we would get x equals 1 and x equals 2. That means that our graph would cross at 1 and 2, our parabola, okay? So for parabolas, we have 3 different ways, and this is on your graphing quadratics functions notes that I had you guys print off, so we can fill these in on the way, okay? We're gonna kind of do both.
Which one? Which paper?
The one that you printed and we're working on, graphing quadratic functions, yes. So, a quadratic function is any equation raised to the power of 2, right? Where it says parabola, we're under definitions. A parabola is the shape of a graph of a quadratic function. Okay? And it's specifically a U-shape. Parabola is a U-shape.
Okay, can you slow down?
A U-shape and a graph.
Shape of graph.
Okay, the vertex is your center point of your parabola. So if you think about it, it's the place that you start going one direction, you're turning around going the other. So if you're coming down, now you're going back up. It's also the folded point along your axis of symmetry. The vertex is the place where your axis of symmetry crosses your graph. Okay, so those are different ways to think about it. Okay, and your solutions.
Anything goes below the vertex, or below the x-axis.
What?
Anything that goes under the x-axis.
Nope. It could be the opposite way too. So your solutions are simply where your function equals 0. And remember, function is simply another word for equation. Okay. So whenever you have a solution, and we had our quadratic where it was set to 0, and we ended up with an answer. So any answers that you get for your quadratic, when you're solving for x, any answers that you get where y is equal to 0, remember? And so when we set the whole thing to 0, right? We're technically setting y equal to 0, right? So when y is equal to 0, right? Then you're along the x-axis, so you're graphing it, okay?
Yeah. Can you say what quadratic function is on definitions?
Any equation raised to the power of 2. So 2 is your highest power. Okay? So your solutions are where it crosses. So solutions, on the next part, solutions to a quadratic function. A quadratic function can have 2 solutions, right? So if I cross the x-axis twice, I can have 2 solutions, right? That would be something like this. That we factored it out, x minus 1, x minus 2, okay? I've got 2 solutions. A quadratic can have 1 solution. That's where it simply hits the x-axis, anywhere along the x-axis, but the x-axis is your bottom line, okay? A quadratic can have no real solutions, okay? If it has been raised above or below, it can also be this direction. Remember, and so then we're going to talk about these. These can all
Who's the
be.
highest one?
Yes. Because 2 is your highest power. Remember that trick? That an equation can only have as many solutions as the highest power.
Yeah.
So when it was raised to the 3rd, then you had 3 solutions. If it was to the 6th, it had 6 solutions.
Yeah.
So that's our trick. So a quadratic at the most can only have 2 solutions by definition. Okay?
What were the solutions also known as?
Solutions are also known as zeros, as roots, or as x-intercept. All right. Now, one more vocabulary that we're going to learn. So we've got we've got the axis of symmetry, the vertex, our zeros where we cross, is that there is a special place on a parabola called the focus. There is a little specific equation for that to find exactly where it's at. But the focus, so the real life practicality of parabolas are mirrors, telescopes, mirrors, all of those things. The focus is a special place that if you were to shine light anywhere on the parabola, the angle in which it would bounce off the side would direct it to the focus. Okay? So no matter where you would shine light, it's going to come straight back to the focus. Okay? On any side. So that is why it's called the focus. That's also why if you have a microscope or something, you are focusing it. So you are moving how the light is hitting the curvature of that lens to bring everything into focus. You're moving it up and down, and you're moving that light so that it's being adjusted, okay? So that's called the focus. So that's the last vocabulary word to know for that one, okay? Now, when we go over a parabola and an equation, a quadratic equation, we're going to start looking at some equations and finding out what we can tell and figure out just by looking at the equation. Okay? Some things that we can tell about the equation, just like with the line, is the direction and the width and where it's located, okay? So those are the things we're specifically gonna look at. In your homework or whenever you are graphing, I will often ask you those three things. What's the shape of it? And I might use the term of skinny or wide, okay? So if we're talking about the shape, we're gonna talk about the direction. So is it up, like a cup, or is it down?
Like it's brown.
Okay. And where is the vertex?
That's a good one. If it's down, it's brown.
Okay. So those are the things that we can find out simply by looking at our equation. Okay. So we can make a table and start filling in numbers, right? But let's think about, I can project the graph up here. Let's think about the original. So y equals x squared, we know, goes through 1, 1, right? Through 2, 4. So we have our basic, there's our basic parabola, okay? So where our basic line was a 45-degree angle and we based it upon that, here's our standard parabola, okay? So our standard parabola, our very first points will always be 1 apart, right? So no matter where you move it, it might be, if this is your vertex down here on these, your first point through is going to be within that square. Okay? Now, what happened when we had a line and this number went up?
It doubled. Or in
What happened to your line? We went from a standard 45, and if now I have y equals 2x, my line got steeper. The same thing happens with a parabola in a quadratic equation. When our a value, remember the coefficient of our first variable, same with a line, when our coefficient gets higher, our line gets steeper. Okay? So now I have, instead of 1, 1, I might be at 1, 2 for my first intersecting point. Okay? And if it's 3, now my parabola is going to get even steeper. I'm going to be at 1, 3. So my line on one side is going to be steeper. So what is happening to my parabola here? It's getting skinnier.
Skinny.
Okay, so we can think about it. So when I'm looking at my quadratic equation, if I just have a 1, I have my basic parabola shape, okay? If I have a coefficient, the greater my coefficient, the steeper that those lines get, just like on linear equations. You see how we're comparing those? The linear equation, your line got steeper, so now my lines are getting steeper, so my parabola is getting skinnier, okay? Now let's think about it. In a linear equation, when I had y equals 1/2 x, right? I started at my 45, and now my slope decreased, so it's a lot shallower, correct? Same with the parabola. So now if I have y equals 1/2 x squared, instead of my first point being at 1, 1, so here's our standard 1, let's think about this. Now when x is 1, y is 1/2, right? So now my line, my curvature is shallower. So the more that this goes down, my curvature is going to be more and more shallow. So what's happening to the width of my parabola?
It's becoming wider.
It's getting wider. Okay? So when our coefficient value is positive in the same way as a linear equation, we're going up, correct? What happened when we had y equals -1/2 for a linear equation?
Goes down.
Our line started going down, right? So our slope was negative, okay? In the same way, if I switch over and I have a negative x squared, that means I'm starting my parabola line down. I'm going to flip it over my axis of symmetry. So a negative term means that I am now facing down. I'm pouring it out. Right? You following?
Yeah.
Okay. So just like we could look at a linear equation, we could look at a quadratic. So if I have y equals 4x, okay, what is the shape of it? Is it 4x squared? Sorry. Is it going to be skinnier or wider than our standard?
Skinnier.
It's going to be skinnier.
Yeah.
Okay. So if I know this is my standard, automatically it's going to be skinnier. Is it going to face up or down? It's going to be skinny, up, and I don't have anything extra. All I have are just my basic numbers, so it's going to start at
Zero.
the origin. Okay, so I can already just kind of graph that it's going to look like that. Okay, so if I have a whole bunch of which graph is accurate, we could already look at all these four and say, hey, I don't even have to solve it. I know it's this one. Yes, question?
I was doing D.
Oh, D.
Sorry, she's in Conic, so
Yes,
she
I'm
can
in that
understand
class.
it. She can understand it.
Okay, now, if I have y equals -1/9 x squared, okay, what is the shape? Is it
Wide.
skinnier or wider?
Why?
It's wide. What direction does it face?
Down.
Down. Okay.
Down.
Where is it located?
Origin.
It's located at the origin. Okay? So if I'm just going to sketch it, I know it's going to be wider and it's going to face down.
If it was like y equals -1/9 x squared plus 2.
That's our next thing.
Oh, yeah.
Awesome.
You were ahead of her again.
Very excited. Okay. So, do you see how we can use just our coefficient to already give us a lot of information about our graph? Okay. Now, like a linear equation, when you added a number, what did it do to the line?
It moved it.
It moved it because if x equals 0, if we're looking on our graph, so if we are looking at x equals 0, so we're looking directly along our y-axis, correct? So we're looking up and down our y-axis. When x equals 0, we now have a number for y. So if x is 0, y is now 2, correct? So on a linear equation, when we added a number, we moved our line. If it was positive, our line moved up, positive. If it was negative, our line moved down. Correct? Because we are removing x and we now have a value for y. It works exactly the same with the quadratic. If I have x squared plus 9, when my x is 0, my y is now 9. So my graph will not start at the origin. It will now start at the point 0, 9. Right? And then I will go whatever direction we have. So let's look at those again. So if we have y equals 4x minus 2, what do we know?
It starts at -2.
Okay, so my vertex, or the point where it starts,
Is -2.
is -2,
And it goes
down here.
up and skinny.
It's skinny, and it still faces up. All right? So I might not have all the exact points, but I have a pretty good guesstimate of what direction I'm headed, right? Miss Shepherd, I don't have a phone or a watch, if you want. Okay?
11:14.
Okay. All right, so when we add numbers, when we add extra variables and constants to our equation, it's going to start shifting it around. If we only add a constant, it only shifts it up and down, right? Because we're removing this one x, we now have a y value, okay? If we add an x value and a constant,
Makes it more confusing.
the x value shifts it left and right. You know, so it's going to affect it and shifting it left and right. And our constant, because that's when we remove all the x's, so our constant affects our y, so our constant shifts it up and down. So now we are moving all directions. We can move it all over. So we're going from the origin. When we simply add a constant, it's up or down. When we do an x, it's left or right. If we have both, we can now move in all directions. Right? See how that's working? Right. So I'm going to, we're going to work through we've done a couple of those already. Okay, so how do we find the origin? Let's start working through an equation. So we have y equals 3x squared. There's also your little vertex, okay? So here's a basic equation that we have. All right, so this is our standard form, correct? We can look at this to solve it initially. Solving it tells us how many zeros and where it crosses, things like that, okay? But to find our values of our vertex, we can transition our standard form into vertex form, okay? Vertex form specifically looks like, and they will put it this way, x minus, I don't know what they have as a value, h. Okay. So just like we had, let's look at if this looked like a linear equation, okay? Remember when we talked about our slope could be an m or a k because it's a constant, okay? And so then that affects where it's going along your y-intercept. That's why they use k in this term. So k is always your y value, your y-intercept. It's your constant in which you're moving, okay? That's why they say slope or constant y equals kx. And k was your slope, and if it's over 1, that would be your rise over your run, your y over your x. Okay, so in that term, so just think through all of math. Anytime they have a k, that is dealing with your y values, okay? So they have added h here for our x value in it. So in this, when we're looking at a linear equation, we're looking at our slope, we're looking at where we're crossing on the y-axis. As we move into quadratics, same thing. We have our slope, this is the curvature of our line, okay, because it's not a straight line, it's a curve, okay. So our A affects the curvature of our line. It makes it skinnier or wide, up or down, right? Our K tells us where we're moving it around. And anything that is added to our x value is going to move us left and right, okay? Specifically this is what you're going to see, this is what you see on your handout. This is also, like if you're in your teaching textbooks, and I'll watch on the different handouts that I give you, they will put it in this term. My personal preference, because as we move into ellipses and circles and hyperbola, they have their y and their k together. And that just makes more sense to me, is to basically keep your y values together, keep your x values together. So if I was going to put my k with my y value, what would I do?
Minus the k over.
Minus a k. Okay, so now I have y minus k equals whatever my number is, x minus h squared. Okay? It also helps me remember that I don't have to switch one sign and keep another sign. In this form, when you get an equation in your vertex form, your vertex is hk, but h is not negative, because the standard form is to have it subtracting a number, but that can get confusing if you have like y minus 3 plus, so you've got that, or x minus 3 plus 4, well, my h is 3, but my y is actually my positive term in that. That gets real confusing for me to remember it in that way. So when you have it in this form, y minus k equals a, and then you've got your squared term, x minus h. My vertex is hk, and it's simply the numbers, because the requirement of the equation is that there's a negative sign, that it's subtracted in that way. So if we have it y minus 3 equals 4x plus 4 squared, the requirement is that I have a negative sign here, so that would be minus a negative 4, correct? So my vertex would be 4, 3. Sorry, negative 4, 3. Okay? So whenever I keep it, let me do one without a negative first. Y minus 3 equals 4x minus 2. Because my equation requires that these signs be negative, when they are both negative, my vertex is simply the numbers. So my vertex here would be what? X is 2, y is 3. This is y. If we set it to 0 and we have x minus 2 equals 0, what is x?
2.
Because I have to add it, right?
Yeah.
So x equals 2. Because we are setting this part to 0 to solve for x. Okay. If I set y minus 3 to 0, what is y?
3.
Y is 3. Do you see why it's the opposite? Because we're solving for it. Now, let's look at this one. If we have it where it is x plus 4, x plus 4 set equal to 0, what is x?
Minus 4.
Minus 4.
Or negative.
Okay? Do you see why that changed it?
Yeah, we should went to geometry.
Okay, so this is only geometry.
It's
So you're
not
good.
it?
No. Okay,
Oh my God.
so let's start with this equation. Here, we want to put this equation into our vertex form, because from our vertex form, we can tell what direction it's facing, right? We know where the vertex is, so it gives us all the information that we need. So when we can transition our standard into our vertex, I can graph my graph, or I can, plot my graph exactly from my vertex equation here, okay? So we're gonna walk through the steps to do that. There is a shortcut, and this is on your graphing quadratic function thing. When you are in the standard form, your vertex, the x value of your vertex, will be negative b over 2a.
I saw that.
Okay? So for this equation, 3x squared minus 6x plus 5, what would be our x value?
Negative 6 over.
Negative of a negative 6
So positive 6 over.
over
6.
2 times 3.
6.
So I have 6 over 6.
1.
1. My x value is 1. So what is my y value? We just plug it in. 3
1.
times 1 is
3 minus 6 plus 5.
8 minus 6.
What? 8 minus 6? 3 minus 6? Oh wait, 8 minus 6. Yes. Oh, so 2.
2. So my y value is 2. So my vertex is at 1, 2.
Well, you did that fast. Third.
Okay.
Oh, yeah.
So now, let's see if we get that same answer. Got it, Ms. Shepard?
Well, I missed something there.
Okay,
But that's-
a cheat sheet shortcut whenever you have your equation in standard form is that the x value of your vertex, because this isn't in vertex form, we're gonna get there. The cheat sheet is that the x value is
Oh, that
negative
is-
b over 2a.
Okay.
And we know that a is 3, b is negative 6. We don't need c.
Because this says that negative b over 2a will tell you where your vertex is.
It does.
Yeah.
It gives you the x
The
value
X That's
of
what
your
I was
vertex.
missing.
And so now that we have our x value is 1, we can plug it back in
Okay,
and solve for y.
got that.
Yep.
Okay? So now let's work through how to transition from our standard to our vertex. And you will need to do this. Okay, this is on your homework sheet of graphing quadratics in all 3 forms. They give you some of that, and then there's going to be another one that I have where you'll actually have to transition back and forth, okay? So I'm going to walk you through this. This is where I said you have to know how to complete the square. Okay, this is why we learned all of this last semester. Okay, so we want to transition it over here. The first thing we want to do is get rid of our 5. First off, can we factor this?
No.
Do we want to try to factor it?
Yeah,
No.
but you had things.
8, 3, is there anything that would do, because that would give us our zeros.
2
And I didn't already try to factor it.
2 and 3.
5 and 1 doesn't give us 6, that gives us 8. That gives us 15 minus 1, no, so we can't factor it. So to find the zeros, or to find the solutions, we would have to
Subtract.
use the quadratic formula
Yay.
Okay. if we wanted to find the solutions
Okay.
for it, okay? So in that case, let's just see if we can figure out where the vertex is, find out what direction it goes, and then see if we even need to find them, okay? So to do that, we need to have, the vertex form says that I need to have a quadratic that is factored into the same 2 factors squared, okay? The way that we get the same 2 factors squared is completing the square, right? So this may be like x plus 2 squared. Remember when we square out the same factors, we get the first factor squared, we get 2 times the front, because this is FOIL, and then we get the last one squared, okay? So remember, we're working backwards. This is the whole point of learning how to complete the square last semester so that we can do this. So we're going to get rid of our 5. We're going to move the 5 over. It's positive on this side, so I'm going to subtract it. So now I have 3x squared minus 6x on that side, okay? The second rule when we learn to complete the square is that the coefficient must be the number 1.
Divide by 3.
Okay, so we're leaving this here, but we're going to take out a 3. Okay? We don't want to take out the x because we are trying to get a squared term.
Yeah.
We're trying to factor it, okay? So we remove the 3. Now I can work in the middle here, correct? What term am I going to put right here to make this where I can square it. The rule for completing the square,
Half squared, or
half, and then you square it.
So
So
one.
half of 2 is
negative one.
One. And
negative 1,
square
and negative 1 squared is?
2.
1.
1.
1.
1.
Okay,
Oh my
so I'm going to put
goodness.
a 1 there. When I put a 1 there, I know that I can immediately rewrite this new quadratic formula as the first term, the square root of the first term, the square root of the last term, and then whatever sign is in the middle, right? And that whole thing is squared. Now, I still have this 3, so it has to stay. It just doesn't go away. Now, we have broken a mathematical rule. We have added something to the right side
And not the rest.
and not added it to the left side. So what should I add to the left side?
1.
Squared.
Okay. We would think that I added a 1
No, you added a
on the
square.
right side, so I need to add a 1 to the left side. But did I really add a 1?
Yes. Oh yeah,
Added
3.
I really added 3. Because this would be distributed out, correct? So since I added 3 on this side,
But you took out 3. So you took it out, then you put it back in.
well, I removed it so that I could get my coefficient of 1 to go ahead and find my completing the square. But if I were to rewrite this back in, I would now have 3x squared, right here, minus 6x plus 3, right? And this would now factor into here. So now I can skip from here to here, correct? Because in that term, I would have factored out a 3 out of all of them, gotten my base quadratic, and then been able to rewrite it and said, oh, that's just x minus 1 squared, correct? So since I really added 3 up here to make my way down here, I have to add 3 to the left side, okay? So what do I really have on the left side now?
Y
minus
2.
Y minus 2. Okay, now I have my equation, my standard equation in vertex form. Vertex form says that my k value and my h value are given to me. They're both negative, right? Or I'm basically solving each one for 2. So x minus 1 equals 0, so x equals 1. Y minus 2 equals 0, so y equals 2. My vertex is 1,
2.
2. Is that what we got?
Is it just a check?
Done.
Is
Wait,
it
no,
like
we're
a
just
check?
checking it?
No, we're working through transitioning it to vertex form. Okay. Now that, because here this was just the shortcut from the standard. Okay.
Do the shortcut
Now-
always work?
Yes, the shortcut always works if they just want the vertex.
Okay.
Okay. But now that I have my vertex form right here, I know my vertex is 1, 2. So I'm going to go 1, 2. So this is where I'm starting. I now get to look at my A value, which tells me about my curvature. What is it?
3.
It's 3. So is it skinny or wide?
Skinny.
So we know it's skinny. Is it positive or negative?
Pause.
So is it facing up like a cup or down?
Up, like a cup.
It's up like a cup. Okay? So now, there's my graph. Right? It's up like a cup. It's skinnier than my base. You know, my standard one. And I'm off. So, right now, if we were to solve this with the quadratic, would we get a solution?
No. Yes.
Would we get a real solution?
No, because it didn't pass the lines.
Okay, we would get imaginary numbers. When you solve this equation using the quadratic formula, you would end up with an I
Oh, yeah.
in your answer. Remember those?
Yeah.
I's in our answers. When we get I's in our answers, we don't have a real solution. And our graph proves that because it does not cross the x-axis. So there are no real solutions. It's also called no zeros. There are no x-intercepts, okay, from this graph.
So if they're
So if they said, what are the solutions of this,
we could just put it in the quadratic form and see.
you could, in like what graph, you would just, if you can put it in the vertex form and say, hey, there's no real solutions for that, without going through the mess of all the quadratic formula as well, okay? So our numbers, so now we're going from, hey, these are all just a bunch of numbers, to we actually can see what this looks like. It gives us some answers, right?
I have a question.
Yes.
He has a question.
So in these equations right here, there is no number, so is it 1?
Yes. Okay. And we're going to walk through those a bit. Okay. Let's see. So to graph a parabola, just as a reminder, to graph a parabola, we need, if they just give us, and they say, hey, graph this, okay? You always need the origin, or the vertex, right? And you need 2 points. Okay? And then we will also, so right now we are getting the equation and we're finding the graph. We're also going to work through, if they give us the graph, how to write the equation. Okay, so for each of our conic sections, we will go both directions. We'll go from the equation to the graph, and then what if we start with the graph? How do we go back and write the equation? Okay, so if we, let's look at, okay, these are just graphing. Okay, so that was just information for you guys. Let's work through one of the homework ones.
Yeah.
Okay, let's do number 4.
A backside going on them? There's a backside.
There should be a backside.
The second one, the backside.
Does it look like
Y equals X.
negative 2x squared? Which one do you have?
Y equals X squared minus 6X plus 5. Is that what you're looking at? Anna?
Okay, because I have a couple of different ones. On the notes. On this one. Let's do the notes first. Okay. Number 4, y equals negative x squared plus 4x minus 5.
Yes, that's
Okay,
it.
let's do that one on the notes.
We did that wrong.
This one, Nathan.
Y equals negative x
Number 4.
squared
Yeah,
plus
we did it
4x minus 5. Okay, so let's use our shortcut version first to find our vertex. What is our shortcut version? Negative
Negative b
over 2a. So our shortcut version says,
negative 4 over 2, basically.
yeah, 2 times negative 1.
So it's negative 2, or positive 2.
So now I have negative 4 over negative 2,
That equals 2.
2. So my x value is at 2. My y value, if x is 2, I have 4 plus 8 minus 5
12 minus 5 equals 7.
Yeah, positive 7.
is
Oh.
7.
I did that so fast.
So my vertex should be at 2, 7. Okay?
Yeah, we did this wrong.
I had a point that
No,
might
which
be-
is wrong.
Wait, what?
No. We did it.
Sorry, this is negative x squared. It's not the negative, so it's this should be negative 4.
Oh, so it's a negative 1.
Negative 1.
Did we do it wrong? Yeah, I still did it wrong.
2, negative 1.
2, negative 1.
Okay? So, we could graph it and do a table. And on there they have you put in tables and you can work through that, okay? Let's just look real quick where we would be at, okay? So let's transition this one to our vertex form. The first thing that we're going to do is get rid of the 5. we're gonna move it to the other side. So we have y plus 5 equals negative x squared plus 4x. Okay? The rule for completing the square is that this has to be the number 1. Is it the number 1?
No.
No, it's negative 1.
Yeah.
So we're gonna remove the negative. Now I have x squared minus 4x and some number. What number am I gonna put there?
4
squared.
4.
Yep, so the half of 4 is 2 squared, so I'm gonna add a plus 4. What have I really added?
A 4. A negative 4.
A negative 4.
A negative 4, so I need to add a
Negative 4.
negative 4 over here. So now I have y plus 1 equals negative x minus 2 squared,
Yeah.
right? Because this factored is the square root of the first one, square root of the second one, and the sign in the middle. Correct? So this says that my vertex is at,
Negative 2.
what is h? No,
2, negative 1.
h is 2, right? So my vertex is 2. Y plus 1 set equal to 0.
Negative 1.
Y is negative 1. Okay, does it match my
Yeah.
cheat sheet? Okay, then that tells me I've gone ahead and solved this correctly, so I can trust the rest of the information I've gotten. Okay, so I have a negative value. I have a negative 1. So is it standard, skinny, or wide?
Standard.
It's standard, and what direction does it face?
Down.
And it starts at 2, negative 1.
Yes.
Is the thing 1, 1? Like, I don't know what's called.
Okay, so then, because it is, I'm gonna,
Like, does it go left 1, down 1?
yes, so, because it is standard, we know that the very first point goes through the next square, right? And I didn't do that I didn't do a good job. Correct?
Yep.
So I could tell you that 2 points on the line, if this one is 2, negative 1, that I'm going to go over 1 and down 1. So a point that would solve this would be 3, negative 2. Correct? And I could go back 1 and down 1, and also 1, negative 2 should also be solutions.
Oh, like the table thing on the left side?
And this. Okay? Yeah, you can put them in the table.
Okay.
Do we fill out these questions like where it says directions, skinny, wide, origin, vertex? Like, do we put...
Yes, so I don't necessarily, on this one, I don't necessarily want you to fill out the table. I would like for you to find your 2 points and then plug them back in to check to make sure that they are accurate and they work. So you're finding your points from your graph and then you're checking to make sure that they are accurate within this equation. Okay, but what I really want you to do is, because this is just a big overall picture of what's going on, I want you to be able to rewrite the equation and tell me what direction does it face. Is it skinnier or wider? Or is it at the origin? And so that would be like a yes or no. And what is the vertex?
Okay.
Okay?
You said this was class notes.
What?
Did you say this was class notes and the other notes?
It's class notes / homework. Yeah, work through that. Okay, and now what is okay, so this one here, the equation parts of that. Ms. Shepherd, what time is it?
It is 11:42.
And we have till 55?
13 minutes.
Okay. So I'm on the one that says equations, parts, and graphs. Let's look at this one.
Yes, answers.
Okay.
Good answers.
So in this one, they are giving us, let's do the first one. They are giving us all
Of the forms.
of the forms, which is great. So this is just, we're going to practice looking at the forms. Okay? and answering the questions. Okay, so the first one, the standard form is negative x squared plus 2x plus 3. All right? So then they have factored it because this quadratic is factorable. So when they removed the negative, let's see, how did they really do that? If they remove a negative, they end up with x squared minus 2x minus 3, correct?
Yeah.
Because we've removed it from all of them out to the front. And then we can factor x squared minus 3 into x. Got a 3 and a 1 and a negative and a positive. Okay, so that's how we got to the factored form. So, but we still have that full negative, or the negative 1 out front. Okay. They also went back and they completed the square on it. So let's look at let's run through completing the square on that one. We would move the 3 over, so we'd have y minus 3, correct?
Yeah.
And then we're going to move out that negative. X minus 2x. We would half it and plus it, so I added a 1, but I really added a negative 1, right? So then I'm going to add a negative 1 on this side, so now I have y minus 4 equals negative x minus 1 squared. They simply put the 4 over on this side.
But don't you want to keep it on that side for the K?
It's personal preference.
Okay.
It will, when they say vertex form, it will always be written this direction. Like I said, my personal preference for HK and not getting confused on changing the signs. You could think of about it if x is 0, so this is the whole thing, it's already there, y equals 4. Okay, it's a personal preference thing. But when they say vertex, they will often write it with your constant on that side. Okay, so we see how they've moved from this standard, and we got all 3 of these equations. We want to know how they ended up with this. Now that they already did, and they ended up with this, we know that our vertex, so the first thing it says our vertex. What is our vertex?
1, 4.
1, 4. Okay? So if our vertex, if we're thinking about it,
1, 4.
this is where you'll need to have graph paper to sketch it out. If my vertex is 1, 4.
So it's up 4 to right 1?
Yep, 1, 4. Over 1, up 4. So my axis of symmetry is x equals 1, right? Because it's all the lines along x equals 1. It'll be that vertical line, x equals 1. The zeros, what are the zeros?
The negative x thing. So it's
Zeros are the solutions, right? Zeros are our answers. So which one of these gives us answers to x?
Bottom one. Wait.
all of them.
Oh.
Whenever they're already set
Oh.
in, right? Because we're going to set y equal to 0. Remember, y equal to 0, anything in the front when we're dividing, it still ends up with 0. Right? So if we set this equation equal to 0, does the negative really matter? Because I would divide by a negative. I would still have 0. So now I set each of my factored forms to 0. Right? This is how we solve them.
3.
So x equals
3. Negative.
3 and x equals
Negative 1.
-1. Okay, so that would be a solution. So when x equals 3, y is 0. When x equals -1, y is 0. Okay, so now I know that when x equals 3, and I already have my vertex here at 1, 4. So when x equals 3, y is 0. Here's a point. When x equals -1, y is also 0. So now I have 3 points on my graph. This is my vertex. So automatically, what direction do I know my graph is going?
Down.
If it's got to go through all of these points. Right? I do know that it goes down because in my vertex form, I have a negative right here, which is really a -1, correct? So that tells me it goes down. Is it skinnier or wider, or is it just standard?
It's standard.
It's standard. All right?
So that means that if you go 1 to the right, down 1, that should be a point.
Yes.
What do I put on axis of sim?
Axis of symmetry, x equals 1. It's going to be this line right here. It will always be x equal to your x value of your vertex. So we knew on this one our vertex is 1, 4. So my axis of symmetry is this one. X equals 1.
What's y intercept?
The y-intercept, those are your solutions.
Oh, I thought that
Okay.
was the zeros.
So your no, sorry.
It's the things on the line.
No, those are your zeros. Our y-intercept is where it actually crosses the line. So if I want to find my y-intercept, what does x have to be?
0.
0. Which one of these is the easiest to solve for that?
Top?
The top one. Because x equals 0, I'm simply
3
erasing all of it. So my y-intercept
is 3.
is 3. So it will cross at 0, 3.
Why does it say reflected? If there's only one.
Okay, because so on this one they're saying if you reflect, that's a y-intercept reflected. If my y-intercept is at 0, 3, where would it be if it was reflected across the line? The axis of symmetry.
3, 3.
Well, I moved from 1, 4, so it's going to be at the exact same line, so there's going to be a 3, right? Y is still a 3.
3, 3.
But I went from 1 to 0, so how
2,
much
3.
did I move?
2, 3. 2, 3.
I moved a space of 1. It's not working. I moved a value of 1, so then I would move a value of 1 on this side.
2, 3.
So it would be at 2, 3.
Wait, is the first one 0, 3, and second one 2, 3?
Mm-hmm.
Oh, okay.
So your y-intercept is at 0, 3. So where do I reflect my y-intercept across?
2, 3.
Your y value on the reflected will always stay exactly the same. So the only thing that you need to do is find the difference between your x value of your vertex in there. Okay? You want to do another one?
What's the zeros?
The zeros are the solutions.
Oh, okay, so that'd be
So we use
-1, 0.
our factored form
3, 0.
to find our zeros.
-1, positive 3.
Yes. So when we have these three forms, the first standard form tells us our y-intercept. All right, correct?
Correct.
So our first standard form tells us our y-intercept, right there. Our factored form tells us our x-intercepts, correct?
Yeah.
Our vertex form gives us our vertex and the curvature and the direction.
Yeah.
Okay. The standard form also gives us our curvature and direction because it is still your A value. But so you can get it from both of them. But our vertex form gives us all of that, okay? So what? Okay, so on this one, let's just look, let's just talk through the second one. So on the vertex of the second one, so we've got x squared. I'm gonna write this down just for those who aren't here. Okay, so we have y equals x squared minus 6x plus 5. They have factored it for us into x plus 5, x minus 1. And then they've given us our vertex formula. Okay? So, what is our vertex?
5. Sorry.
What is the vertex?
3, -4.
3, -4.
Yes.
If this was moved over,
Yeah.
it would look like that. So, our vertex is 3, -4. Okay? What is our axis of symmetry? x equals 3. Correct. Okay. What are our zeros? The zeros are the solutions. So we're going to use our factored form.
So that's 5 and 1.
5 and 1. And these are coordinates. They are telling us when y equals 0. So we have 2 solutions for that one. Okay. What is our y-intercept?
Yeah.
You don't have to graph anything yet. What is our y-intercept? We're just answering all the questions.
5.
5. And so that gives us the answer. So what our x value is 0. Don't forget these are all coordinates. X is 0. So our y-intercept is 5. That means x is 0.
Just a lot of coordinates.
All right. So now, for the reflected, I know it's still going to be at 5, right? Where did I go from my vertex? I went from 3, right?
Yeah.
So I went from 3 to 0. So the difference is 3. So I'm going to need to go 3 on the other side. So it would be 6. 6, 5. Okay. So now we can graph. We know our vertex is 3, negative 4. Okay. I know I've got standard. It's a standard form. It's positive. It goes up. So it's already going to be going up. So from 3, negative 4, I'm going to work on my little boxes, right? So again, use graph paper. Makes life easier. Okay. I know I'm going to cross the x-axis at 1, 0 and 5, 0. Correct? And I'm going to cross the y-axis at 0, 5. And that means I also have 6, 5 over here. So now I have 5 points, plus I know it was standard, so I have 7 points, because I know those have to be within the box that I can graph my equation.
Okay, you guys made it right.
Okay, so the x, does that go up and left or right or down first? Like 0 and 5, where's 0 and 5?
It's always x, then y.
But like, is it, oh my goodness.
5 is overrun. Or
Yes. So our slope in this case would be 5 if we were looking at it as a linear equation. But it's always x and y. So when x is 0, y is 5.
And
Alright.
so then 6
Perfect.
is 1, 2, 3, 4, 5, 6.
do you just put little arrows saying it goes off forever?
Yep. And just put little arrows at the end. Alright. So now we've gone from having a simple quadratic equation that to us was just a bunch of numbers and letters to it actually has a shape. Got it?
Yes.
Alright. Next week we will work on going from our graph of our parabola back to our equation, and we will add circles and ellipses
Are you
and
gonna
extra things.
use to look
Yes.
at?
Doing this, Robert.
Alright.